We'll proceed on vector field. So vector field we have talked, and little bit we have talked about the line integral in the vector field. Vector field is future in calculus. This is what we have already stated. So vector field is a future in calculus. So calculus is a game of algebra. If calculus is game of algebra, then vector comes into the picture where we have algebra with direction. If I need a algebra, if I need an algebra where it has direction also, algebra with direction also, then it is nothing but it is vector field. So vector field is algebra with a direction. Okay. So if I have algebra, if I have a function f, function over x, this means that fx is a function over x. It can be x square, it can be sin x, it can be cos x plus sin x, so and so. So if I put value, if I substitute value of x in fx, then I get a fx value. So y equal to fx, then x if I put, then I get fx. Okay. So a function fx over x is nothing but it is a algebraic equation. Whereas a vector, so a algebraic equation, if I put parametric value, function f over x, as I say, it is related to Python function where it takes x as argument to the function or parameter to the function. If I pass x and then it does internal computation and returns y. So y equal to fx. This is how we call the Python function. Now here in calculus, it is same as function over x, but x is called independent component. So if x is independent component, then function over x, if x is independent component, then function over x returns a value that is called dependent component. Y equal to fx. If y equal to fx, then fx x being independent component, function over x returns a value that is y. Straightforward. Now, what is a vector field? A function produces a scalar value provided the independent components. Vector field also takes independent components, but it returns vector. Okay. So if a function returns a scalar value, then vector returns a vector. Suppose I have a vector, so we can call it as vector function or vector field. Vector field is denoted by capital F. Capital F x comma y. Capital F means it is a vector function, vector field over independent component x and y. If it is over independent component x and y, then what is the formula for the vector field? Then formula for the vector field is, suppose it is x plus y I. I is x axis plus x into y j. This is the kind of vector field equation. X plus y I plus x into y j. If that is the case, then if I pass any value of x and y, then it returns v a vector. If x is 1 and y is 2, then it is 3i plus 2j. 3i plus 2j. If x is 0 and y is 2, then it is 2i plus no j. Okay, x plus yi plus x into yj. If that is true, then keep changing the x and y and keep getting one vector. So vector field is a kind of vector function which returns a vector provided if we provide the xy parametric values. If I have algebraic function, Then independent component, if I provide, returns me a value. If I have vector function, then if I provide independent variable, then it returns me a vector. This is vector field. Now the idea is, suppose the vector field is a force. Vector field is a force, and force is imparted on an object. Object is moving in one direction. Example I have given. If this is the object, then certainly it cannot move in this direction. I have to lift it. But if you make any force, then it will move along horizontal direction. Can you see? I am giving force exactly the way it should move. But now I am giving force in this direction. It is moving little slow. If I give force completely vertical, then it would not move. It is pressing the table, but it cannot move the way I want it to move. That is what I'll call it work done. So if I have a force, if I have a force and force is falling on an object, so force is a vector and falling in an object has a direction. The direction is along x-axis. Direction is along x-axis where force is a vector which has, so the direction has equation like I. Direction has equation like I is x-axis, where force has equation like I minus j or I minus 2j. So it is downwards. And then when it is placed, it is moving it. Suppose it moved it 10 meter, 10 unit. It moved it 10 unit where the force is I minus 2j. Then how much work done? How much is the work that this object has done because of this force? So that is the this force x component. If this is the force, it has x component, it has a y component. Vector, I also call it energy. Vector is energy. Vector is energy which has x component, y component. Vector is energy which has x component and y component. I mean, if there is a energy moving on, then person standing on x-axis, he may get feeling of the energy. If energy moving this direction, person standing on x-axis, he is feeling some energy. Person standing on y-axis, he is feeling some energy. How much this person, because of this energy direction, how much this person is feeling the energy is, if if v is the vector, then v cos theta, v sin theta, where theta is this angle. So V dot product of this unit vector is the V energy essence along x-axis, V dot product with this axis unit vector, then V essence along this axis. If this is the force, if this is the force, if this is the force, if this is the force that is falling on this object, because of that object is moving, because of that object is moving, okay, object is moving, then the, if this is the vector v, then v dot with x-axis, whatever comes, that is the this v's energy along x-axis, then multiplied by the distance this object has traveled, that much energy, that much work done is done by, work is done by this object. So if it is I minus 2j and this is I minus 2j and this is I, but movement is 10 unit, so I would call it 10I. Okay, so I minus 2j dot 10I, so j will go away, so 10. So 10 is the unit that is work done. So straightforward, right? With vector only I am able to do everything. Then why we need calculus? Calculus is game of algebra. Calculus is game of algebra. Like 3D programming is game of vertices. 3D programming is game of vertices. Machine learning, artificial intelligence is game of information. How much information is contained? That's it. Okay, you make 10 feature, 20 feature, 30, a data set has 5,000 features, and then we have so many samples, and then this is very powerful data set because it's at 5,000 features, and then 10,000 samples. Doesn't matter how much information the database contains. That is the important. So how much your features are orthogonal to each other, then only you will carry the maximum information. So energy, how much it can. So energy in machine learning, that the energy in machine learning, the data set which carries the energy, it is something like how much orthogonality we see in the features. Whereas if I draw the 3D programming, then energy that 3D programming contains is how many vertices are there. That okay. If we see electronics, then electronics is game of resistance. If resistance is constant, then if you have voltage applied to it, there will be current. But if resistance is varying depending upon the temperature, sometimes resistance vary depending upon the voltage itself. If voltage is high, then there is no resistance. If voltage is low, the resistance will keep changing, like diode. So electronics is game of resistance. If you understand resistance concept, then you are done. Like that, the calculus is game of algebra. Calculus is not the game of infinitesimal small. This is what I keep telling. That generally people, whatever book you see, there will be discussion on infinitesimal small. If we take, then there is a limit, and then it will look like this. And then for that small region, if I calculate the value, then you have to keep adding and make it global, and that is the total integration. This is not calculus. Calculus is pure game of algebra. Anyway, so vector field, so vector we saw now, the vector is a straight, vector is anyway straight, falling on the object, and falling on the object, and object is moving, where vector field comes into the picture, and calculus comes into the picture. Where vector field will come into the picture, calculus will come into the picture, because vector field is nothing but a vector function generating the vector, where vector function has algebra. So vector has components, x component, y component, z component, where each component is a function over independent component. So if I have, or I can say vector field has component 1, 2, 3, 4, where each component is a function over x, y, z up to n, whatever the components. So this is, so when algebra is, function means algebra. When algebra is pushed inside vector field, then we have hybrid model of vector and algebra. When algebra is there, we can do differentiation and integration. If that is the concept, we can do differentiation and integration. As far as algebra is concerned, then vector field comes into the picture. Why vector field comes into the picture? Now, suppose that, oops, okay, suppose that this is our mass, and this is the vector that is being applied. Now vector is like this. So it is pushing the mass. It pushed for 1 meter, suddenly vector become like this. Then again it pushed mass, then suddenly vector become like this. Then it pushed the mass, then suddenly vector become like this. It pushed the mass, not it cannot push because it is now 90 degree. Now vector become like this. Now it pushed the mass in opposite direction. Then vector become like this. Then again it pushed. Then suddenly vector turned like this and it started push. So during the course of 10-meter move, now vector made 5 changes. Vector made 5 changes. If vector makes 5 changes, then certainly we cannot calculate the dot product with single vector. So suppose that it makes movement of x1, x2, x3, x4, x5, where any one can be negative. So at x1 movement, the vector is f1, x2 movement vector is f2, like this f5. So f1 dot x1 plus f2 dot x2 plus f3 dot x3 like f5 dot x5. If I these five dots, then after that if I do these five dots, whatever comes, that is the work done. Okay, so now we are coming to a calculus. Calculus in a sense that suppose in 10-meter move, vector makes 10,000 changes. 10,000 times vector change along 10-meter movement. Now 10,000 times you will add, do multiplication and add. Person will die only. Not possible. Okay. So what is required now? If someone tells me that vector is changing 10,000 times the direction during movement of the object for 10 meters, then can you tell me what is the work done that is seen on the object? Not only that, vector is changing the direction, vector is changing its magnitude also. Vector is an energy source which has a direction, vector is energy source which has a magnitude. So vector keep changing its direction and vector keep changing its magnitude. Both. Okay. Now this direction is flat. The direction is straight line. Direction is straight line. What about this direction is not a straight line? The way it is a curve. Now, if this is the vector, then vector is applied on this object and object is moving in a curve, not in a straight line. It is in a curve, and this force is vector force is keep on changing everywhere with magnitude and direction. Whereas this is also not a straight line. It is a some curve or it is a rectangle. It is a rectangle. When it is a rectangle, then it is not a smooth. If the line along which object is moving, if it is a rectangle, then one line is smooth, then there is abrupt change, then another line is smooth, another. So four kind of disruption is there. Just try with someone and tell him that the object would move in a curve and suppose suppose if this is the if this is the object that has to move, then it has to move along the curve, and the force that is being applied, being applied and it is changing its direction and magnitude both. Can you tell me how many times it is changing? It is changing 10,000 times when there is a movement along 10-meter distance in a some curve. That equation I don't know. Then can you tell me how much energy this object is receiving from this vector? 10,000 times. Then certainly either he would, if he tries, then he will go mad or he would run away. So algebra comes into the picture. There are two-way integration is done. Anyway, calculus is done. One is through algebra, upon which the integration is based upon. Okay. So what is required? Requirement is I have to find algebraic equation of this curve and algebraic equation of this function. If I provide algebraic equation of this function, then at each point on the curve, it is x0, y0, 1 point, x1, y1, 1 point, x2, y2, 1 point. Like that, x 10,000, y 10,000 is another point. So it makes 10,000 points along the curve. At each point, the vector is different. This proves that this vector is algebraic. It has algebraic equation. This is called vector field. Vector field is nothing but a algebraic equation for vector where the first component, second component, two components are function over x and y. If it is a vector, it has components. First component, second component. If it is a vector, then it has component. First component, second component. Two dimensions. First component is function over x and y, that is fxy, and second component is function over x and y, that is gxy. So capital F is vector function. Capital F braces x comma y equal to fxy I plus gxy j. So this vector, this is called vector field. Vector field is nothing but a vector which has components which are algebraic functions. Now passing the independent variable in the algebraic function, they return one particular vector. Keep changing x and y, keep receiving different set of vectors. So if it has 10,000 x and y from x0, y0 to x 10,000, y 10,000 along this path, then at each path the vector that is generated by vector field as per the algebraic equation is different. Now, rather than going with those differences, algebraic equation takes care of everything. If I have algebraic, it is a algebraic equation. It's a function over x comma y. Now, function over x comma y. So, if I say if this is a path, so path is called R. Path must be piecewise smooth. Piecewise smooth in the sense this path is smooth. But if I make it a rectangle, then it is not smooth. It is piecewise smooth. If I take four pieces, horizontal, vertical, horizontal, vertical. If I take four pieces, then it is smooth in every region. But all along, it is not smooth. But this curve is smooth. So path must be smooth. That is required. So if we don't have a smooth path, then you cut into segments. Each segment should be smooth. Now, if I have vector field F, that is vector over algebra, so vector field F dot product with R, if R is the path, F dot R or F dot dr, F dot dr, then if I integrate, then I get the work done. Work done is force into displacement. Force into displacement. Okay. Now displacement is algebraic equation. So I should not say this is the bookish word. F dot dr, F dot dr integration is the net work done on the object, force into displacement. But I would say F dot r, F algebraic equation over vector, and R is algebraic equation. Now, since R is a kind of a curve, so R can also be a kind of a, okay, so it can also be a vector field, okay, vector field in the sense that it is has some direction at each point. Okay, it has some direction at each point. So if I see at this point, then the direction is like this. At this point, direction is like this. At this point, direction is like this. So curve is also a kind of vector field, and force is also kind of vector field. Both are algebraic equation. If both are algebraic equation now, then I can do force dot then path. Force vector dot force vector field dot path vector field. That's it. If both are algebraic equation, then from what point to what point I want, I would do the integration. Integration is nothing but calculation of area. We will go minute into it. Like, what is a force? If force into displacement is work done, then work done by displacement is force. D work done by D displacement is force. If that is true, then per unit change in the distance brings how many unit change in the force is what is the how many unit change in work done, d work done by d distance. If one unit of distance if I take, then how many unit distance I see in the work done? D work done by D unit distance. D work done by D distance. That is the force. So if I say that if I have an algebraic equation of D work done by D distance, then if I have a distance x-axis independent component, if I have a distance as independent component, then I have algebraic equation as d work done by d distance. Then if I want work done, then I have to calculate the area of the curve along the axis, that is distance. This is pure integration. So if I have algebraic equation of d work done by d distance, dw by dt, work done by distance, that is in algebraic equation, then at any point if I calculate the area, then I get total work done from the beginning. But from one location to other location, then I have to place the limit. If I place the limit, underneath if I calculate the area, that is nothing but the work done. D work done by d distance. If I calculate the area of the graph, then it is the work done. So force is d work done by d distance, that we should consider in that fashion. So force vector field dot the distance vector field. If I do dot product of these two, then I get force. Okay, consider that displacement is unit vector. Consider that displacement is unit vector, but still it is algebra. Even though it is unit vector, but still it is algebra. Vector algebra. Here vector algebra, here vector algebra. So force, the force vector algebra. Why it is algebra? Because it will keep on changing as per the value of x. The force vector will keep on changing as per the value of x. Similarly, the path unit the path unit vector will keep on changing as per the x. Now, if I do dot product of these two, then I get force, then I get the work done for one distance. Okay, now if I want full distance, then full integration I have to take from left and right. So force vector dot product with unit vector of the distance, if I take, then more or less I get the actual dw by dr, dw by d distance. Now if I integrate this algebraic equation, then whatever comes, that is the distance that I have to place the limit upon. Why I am doing dot? Because force has to be in sync with the distance, same direction. So force dot unit vector, force dot unit vector is part of force only. We should consider in this fashion. If I have two axes, one is independent component, one is dependent component. If independent component is distance and dependent component is force or d work by dr, then d work by dr is nothing whatever force we have dot unit vector. Force dot unit vector, whatever comes, that is actually d work by dr, because it has to be in the same direction of the r, the path, the distance. So force vector dot unit vector of the distance. Then if I do whatever the algebra what we are receiving, that is actually force algebra. If they are in same distance, same direction, then dot product is not required. Okay, we can kind of do the force into displacement. Simple, the limit I can apply force into displacement. But if force is not in direction with the displacement, the force dot unit vector of displacement, that will constitute the actual force, effective force in the direction of distance. So first, I think that is the better word. So if I have this direction as the path and this is the force dot with the unit vector of this direction will compute item that is called, okay, so that is called effective force. So if I say that I have a item and I have applied the force, now you tell me how much it would move. Someone would ask, what is the effective force? Effective force is zero in this direction, no movement. If this is a force, then someone would ask, what is the effective force? Effective force is this force dot product with this unit vector. Whatever comes, that is the actual force. So F, vector field F dot the unit vector along I want the movement, then that dot if I do that, then I get effective force. If I get the effective force, then integration of that effective force during the in the direction of the direction, then it will give me the work done. So F dr integration give me the work done. Now F is effective force that we are calculating. So if this is the path, then at each point the effective force is this force dot product with the direction. This force dot product with the direction, unit vector of the direction. If force is like this, then dot product with the force is negative. If force is perpendicular, then dot force. So there is no force. So at each point, the effective force is different. So effective force, I have to calculate at that point, then a small distance if I take, then for that small distance, how much is the work done? You understand? So what is the small distance? So if I start from x0, y0, where I have the force and force changed at some point x1, y1, but meanwhile during that this path keep on changing. Path is changing everywhere. Force is not changing everywhere. It is changing at where, at x0, y0, x1, y1, x2. So in full path it is changing 10,000 times, but the path is changing every moment. So I can take a small distance, very small distance. If it is path is r, then I'll take delta r. Now I have 10,000 r, r0, r1, r2, r 10,000. There are 10,000 sections I have done, or I can do as many sections I want. Suppose I have done n section. N is may not be 10,000. 10,000 force is changing. So I take n. So if it is r0, then it is r1, then it is rn. I consider that between R0 and R1, that it is delta R, and delta R is a straight line. This is what I don't like. This is another way of integration. If delta R is a straight line, then if I have a vector F, then F dot the line what I am taking. If this F is like this, and between R0 and R1 the line is like this, then F dot this unit vector, that is the effective force, into this distance is the work done. So if I have this arc as a as a path, along the path our object would move, then at each point on the r, the vector of the r is different, and at each point, okay, suppose that f is also different at each point. I had taken 10,000. Suppose f is also variant at each point. This is a function of x and y now. So if that is the case, then I divide it into n section. If it is in n section, this is R0, R1, R2, Rn. If this is like this, then R0 to R1, if I take, then distance is delta R. If distance is delta R and direction is and if distance is delta R, and here the R vector, R1 vector, if I subtract R1 minus R0, then it gives me the R1 minus R0 by delta R. R1 minus R0 by delta R gives me the unit vector. So F dot the unit vector gives me the effective F along this direction. So that much into delta R would give me the work done. If that is true, then I can call it that F dot delta R. So delta R means delta R has a direction. F is a vector dot delta R vector. Okay, if delta r is the direction, then f dot delta r, direction and magnitude both. Okay, understanding. So f dot unit vector is the effective force, and then multiplied by delta r gives me the work done, or f dot delta r vector. Delta r vector has unit vector and magnitude both. So f dot delta r gives me work done for one section. If I add for all the n section, then I get the total work done. So I have summation now, where I equal to 0 to n, I equal to 0 to n or 1 to n, whatever, f dot delta r I, f or fi vector field at I have a summation I equal to 0 to n, I equal to 0 to n, fi dot delta r I. Then this summation, if I make for all, I get the total work done. That is nothing but f dot dr, f dot dr integration from lower limit to higher. Okay, this is now it came to the calculus. At the end, it came to the calculus. Now, when it came to the calculus, now f is algebraic function and r is algebraic function vector. Then at each xy, this vector is different, but calculus takes care. If I provide my function as algebraic equation, and then if I do integration, then calculus takes care. So all these variations, calculus takes care. So now I have, this is called line integral. Instead of force vector field, I call it simple vector field. So vector field dot displacement vector, vector field dot displacement vector. Then if I integrate along the full line from beginning till end, then this is called line integral. Line integral means if I have a vector field, that vector field, if I apply dot product with the line vector, f dot f dot dr, and then I integrate from one end of the line to another end of the line, then I get the line integral. Line integral of force is work done. Okay, line integral of velocity vector with time is distance curve, where path is time and vector field is velocity. Then velocity by time, velocity into time is distance covered. If the vector field is force and path is distance, force into distance is is the work done. Now depends upon whatever the vector field. So vector field multiplied by the line, multiplied by the distance line is line integral. If they are not in the same direction, then dot product. Vector field dot product of the line and then integration over the full line is the line integral. I believe nothing can be clear if we take until we take the example. So let's consider that there is a vector field. There is a vector field called xi plus yj. Vector field is xi plus yj. So if I take x-axis, then vector field has only direction along x-axis because y is 0. If I take point on y, then it is only along y. Otherwise, as per the xy value, the vector field. If that is the case, then what is the line integral? Okay, vector field can be force, can be velocity, can be magnetic field, whatsoever. I don't worry. That has to be multiplied with the distance. Okay, that is the concept. So now the distance is a line, is a line that has two pieces. One is from 0 to 10 along x-axis and another is 0 0 0 0 to 10 0 and then 10 0 to 10 9. X-axis along 10 and y-axis along 9. So this piece and this piece, how much is the line integral? If that is the case, then xi plus yj dot first piece is first piece is direction is I. So the effective force is xi plus yj dot I dx. Okay, because it is in x-axis direction, so I would say dx. So I can remove and I can say dx, okay, or dxi. So I can now call xi plus yj dot product of dxi. It would result in x dx. If it is x dx, then x square by 2 is the integration from 0 to 10, means it is 100 by 2, that will come as 50. So 50 is the work done, that is done on an object from 0 to 10 if the vector field is xi plus y. Like from this location to this location, that height is 9. How much is the work done? That is xi plus yj dot dy, because it is only in this direction, dyj. Now it will come as y dy, y dy, y dy. Now I have to integrate from, you can consider at 0 to 9. Okay, so y square by 2, then it is 81 by 2. So 100 by 2 plus means 50, 50 plus 81 by 2. That much is the work done. That much is the line integral, not the work done. So that much is the line integral. Okay, so this is kind of beginning of the line integral. Okay, so line integral is nothing but if I have a vector field that keep on changing, and if I have a direction that also keep on changing, then what is the multiplication of this vector field with the direction? So first we have to do dot product. So I get the effective vector field along the direction, and then we have to calculate this dot product, then multiply by the distance. So vector field is a straight line and path is a straight line. If you take dot product of vector field with unit vector of the direction, then we get effective vector field along the direction. Whatever effective vector field I get along the direction, this description is not available in any of the books. That you have to calculate the effective vector field along the direction. So once we get the effective vector field along the direction multiplied by the direction length give the line integral. Okay. So now this is the concept. So we have now vector field xi plus yj, and the line is is in two pieces. One is from 0 0 to 10 0 and then 10 0 to 10 9. Now calculate the line integral. One piece we calculated along x-axis, one piece we calculated along y-axis. Both work done, if I add, that much is the work done. Okay, so we will proceed in the line integral, but what is the questionnaire for this session? What is the questionnaire for this session? Okay, now suppose that I have I have x-axis, I have x-axis and I have y-axis. So if I have x-axis and y-axis, then I have a circle. Okay, if there is x-axis and y-axis, if this is x-axis and this is y-axis, then there is a circle. Circle has four quadrants. One is this quadrant, this quadrant, this quadrant, this quadrant. So first quadrant is positive x positive y, second is negative x positive y, negative x negative y, and positive x negative y. If there are four quadrants, then in the first quadrant, only first quadrant, this is the line. First quadrant, this is the line of the circle. Now circle is of radius 1. So the equation of circle is x square plus y square equal to 1. Vector field is xi plus yj. So vector field is xi plus yj. If vector field is xi plus yj and first quadrant, if I take the line, then it is 1 comma 0 going till 0 comma 1, okay, with radius 1. What is the line integral of this vector along this line? Vector field is xi plus yj. Xi plus yj along a curve that is x square plus y square equal to 1. That is a circle for the first quadrant. What is the line integral? Okay, it can be solved by two ways. One in Cartesian coordinate and another in polar coordinate, or polar coordinate in the sense that is also called parametric vector. Now in parametric vector we will have one independent variable, that is t. So if this is the path, this path is in x and y right now. If I convert this path into t, like a cos ti plus a sin tj, where t is the radius. So then equation of the circle is a is radius, it is 1 now. So cos ti plus sin tj. If that is the path vector now, and another vector is x I plus yj. So this vector field, when it is touching the parameter of the circle, at that moment it has equation the same as x and y that is taken along the curve. So we can place it there and then we can calculate the integration with the t1. So now it will convert to dt rather than dx dy, it will convert to dt. Then we can do the integration, or purely we can do in dx dy in Cartesian coordinate. So both form, someone has to calculate vector field is xi plus yj for the first quadrant of the circle, that is a perimeter, and equation is x square plus y square equal to 1. Okay, so this is the questionnaire for the video. For that session, for that you have to calculate the line integral, that is f dot dr integration. So okay, so that we will see what would is the result later. I mean, I have given the answer, but let's see if someone can really solve it. So we have WhatsApp number. So if we see WhatsApp number, that is 94831 60610. So this is the WhatsApp number, that is India 91 plus 91, India 91 is the country code, and then 94831 60610. Probably you would find in the kind of about section of the channel. This is the contact WhatsApp number, 94831 60610. Country code is India, that is 91. So calculate the line integral through any of the way. If you do through both way, then it is very nice. And then send your whatever. You can write down on a paper, take a photograph, and send on this phone number. So this is what we are waiting.